Dear students, welcome to our science episodes. Today we are going to continue discussing fundamental forces in nature. In the previous episode we discussed gravitational force, and in this episode we are going to talk about electromagnetic force and nuclear force. Electromagnetic force. It is the combination of magnetic and electrical forces together. It is the physical interaction between electrically charged particle, in another word we can say electric current flow, within a magnetic field. So we have a magnetic field, these blue lines, between two poles of a magnet and an electric current passing in the middle of this magnetic field. This combination will create what is called electromagnetic force. Let's think about this activity together. Magnetic forces of electric current. We will need scissors, a long insulated copper wire, a soft iron bar or an iron nail, a dry battery, 4.5 volts, iron fillings, and two open-ended plastic tubes. What we are going to do is we're going to coil the wire in a spiral shape around the plastic tube as shown. Look to this copper wire. It is coiled around the plastic tube. And then we are going to insert the iron bar or the iron nail in the tube. We're going to connect the two ends of the wire with a battery. Then approach the iron core inside the tube to the iron fillings. When the electric current flows, the iron bar or the iron nail inside the plastic tube will attract the iron fillings. And by this, we can prove that electric current has a magnetic effect. This is an electromagnet. It's made of an insulated copper wire coiled around a bar of soft iron. And when an electric current passes through the coil, it works as a magnet. What are the uses of an electromagnet? In our life, you can see electromagnets in many devices, such as the cranes which lift scrap iron in cars. This part is an electromagnet. And it is used also in making electric bells. Electric generators and electric motors depend mainly on electromagnetic forces to work. Here are electric generators. They are devices that converting the mechanical energy into electric energy, such as the dynamo. But what about electric motors? They are the opposite. They are converting the electric energy into mechanical energy, such as the electric motor in the fan or the blender. Now we are going to talk about nuclear force. Before discussing nuclear force, we have to talk about an atom. What's an atom? An atom is the smallest particle that makes matter. An atom consists of a nucleus in the center and orbits around this nucleus. But where is the nuclear force? Let's see together. This is the atomic structure. This is the nucleus with positive and neutral particles, protons and neutrons. And these are the orbits containing the negatively charged particles called electrons. An atom stores a massive amount of energy inside its nucleus. And scientists succeeded in releasing this nuclear energy and use it in many purposes. This massive energy is accompanied with nuclear forces. Types and uses of nuclear forces. We have weak nuclear forces, and we use these forces to get radioactive elements and radiations used in medicine, scientific researches, and in industry. And we have strong nuclear forces. They are producing electric energy and used in military purposes too. For example, in producing nuclear bombs. Now it's time for questions. Write the scientific term. An insulated copper wire coiled around a bar of soft iron that works as a magnet when an electric current passes through the coil. This is, of course, an electromagnet. The force responsible for attraction of the particles inside the nucleus of an atom, even when there is repulsion between protons inside the nucleus. This is strong nuclear force. They work on converting electric energy into mechanical energy. Electric motor. Now, give reason why is the magnet in an electromagnet made of soft iron. This is because soft iron is easily magnetized by the flow of electric current. Thank you. Dear students, thank you for watching and see you later in other science episodes.